Hello everyone, today we're going to talk about the Pythagorean Theorem. So the Pythagorean Theorem is right there. It's a squared plus b squared is c squared. And we basically use it to solve for missing sides of a right triangle. Okay, so if I have this right triangle right here, and this is my right angle, A and B are always the legs of this right triangle. So the legs of a right triangle are always attached to the right angle. And C is the hypotenuse. So C is going to be across from that right angle. So that's how we always label things. Make sure that C is always the hypotenuse, okay? So an example here, find the length of the third side. If necessary, round to the nearest tenth, okay? So since this right here is my right angle, okay, this over here is C, I can call this A, and I can call this B, all right? So using the Pythagorean theorem, I don't know what A is, so I'm gonna say A squared plus 13 squared is equal to 20 squared, okay? Let's go ahead and square these numbers. So I have A is equal to 169. Back up. A plus 169 is equal to 20 squared. It's going to be 400. And then we want to get A by itself. So we're going to subtract 169 from both sides. And I end up with A squared is equal to 231. So now if I want to get the A by itself, the way I get rid of that exponent is I take the square root of both sides of my equation here. So I end up with A on the left side, and then when I take the square root of 231, let's use our calculator for that, and notice the instructions say to round to the nearest tenth, so we want to make this a decimal. So square root of 231, and that is 15.2. And since we're rounding that, we're going to say this is approximately 15.2. And that is our missing side. One thing to check real quick, the hypotenuse has to be the longest side. So this is shorter than that hypotenuse.
This is the 1 minute.
If I had gotten something longer than the hypotenuse, then something's wrong. I need to go back and look at it. Okay, here's another example. So again, the hypotenuse is across from the right angle, so that's C. I can call this A, I can call this B. Okay, A and B, it doesn't matter if I switch them. I could call 12B and 13A. I'm still gonna be okay there. So on this one, I have 12 squared plus 13 squared is equal to C squared. All right, so 12 squared is 144. Plus 13 squared is 169, and that's equal to C squared. So 144 plus 169, that's going to be 313 is equal to C squared. And then I just need to take the square root of both sides. So square root of 313 and square root of C squared. That's going to give me C is approximately, square root of 313 is 17.7. Okay, here's another example. It says one leg of a right triangle measures 4 centimeters. The other leg measures 8 centimeters. Find the hypotenuse. If necessary, round to the nearest tenth. Okay, so on this one, I'm just going to draw a right triangle. So this is a right angle here. I'm told that one leg is 4. So let's put a 4 there. The other leg is 8, and we don't know the hypotenuse. We're finding the hypotenuse. So again, I could say 4 squared plus 8 squared is equal to C squared. Okay, so 4 squared is 16, 8 squared is 64, equal to C squared. End up with 80 is equal to C squared. So then take the square root of both sides. Okay, so we end up with C is approximately, the square root of 80 is going to be 8.9. And that's it. All right, here's another one. Again, we're given a right triangle. So let's just go ahead and draw a right triangle here. And we're told the hypotenuse is 14. So let's just go ahead and put a 14 there for the hypotenuse. And one of its legs measures 3. So I'm going to put a 3 there. I don't know this one. So we have 3 squared plus b squared is equal to 14 squared. Okay, so let's go ahead and square everything. 3 squared is 9 plus b squared is equal to 14 squared, which is 196. Okay, so subtract 9 from both sides, and we get b squared is 187, and then take the square root. Okay, so the square root of 187 is approximately 13.7. And that's it there. All right, so this problem is pretty much the same thing as what we've been doing. Just notice that we have radicals now. And also it says to put your answer in simplest radical form. So we don't want to have a decimal here. We're gonna leave our answer as a radical. So let's use the Pythagorean Theorem here. So I know that this is C. I can call this A and this B. So I have a squared plus 7 squared is equal to the square root of 74. And let's put parentheses around that, and we're going to square that. Okay, so now a squared will just stay as a squared. 7 squared is 49. Okay, the square root of 74 will just be 74. Okay, that square, these two things just cancel each other out, and that number just comes out. Because basically I have two 74s here. So that's why a 74 is able to come out. So now subtract 49 from both sides, and we're gonna get a squared is equal to 25. Okay, take the square root of 25, and a is 5. Okay, so that's all there. All right, and here is another example. So we're trying to find the hypotenuse on this one. So this is the hypotenuse, this is A, and this is B. So I have 5 squared plus root 11 squared is equal to C squared. So 5 squared is 25 plus 11 is equal to C squared. If I add these together, I get 36 is equal to C squared. And the square root of 36 is going to be just 6. And that's it there. If I happen to get a radical for my answer, I just need to simplify it as much as possible. But these happen to be 36 is a perfect square, so it came out cleanly. Okay? So please check out the assignment on Canvas and let me know if you have any questions.